Relate temperature to the initial average kinetic energy of the gases. According to kinetic molecular theory, the average kinetic energy of a gas sample is directly proportional to its absolute temperature. Ke average is proportional to T. Because the 1.0 mole sample of say is initially at a higher temperature, 50 degrees Celsius, than the 1.0 mole sample of He, 25 degrees Celsius, the xenon atoms initially possess a greater average kinetic energy than the helium atoms. Understand the thermal equilibration process. When the two gas samples are mixed, their particles collide with one another. Through these elastic collisions, kinetic energy is net transferred from the hotter, higher energy gas particles, say, to the colder, lower energy gas particles, He. This transfer continues until the mixture approaches thermal equilibrium, where both gases reach a shared final temperature, between 25 degrees Celsius and 50 degrees Celsius, and therefore have the same final average kinetic energy. Determine the change in average kinetic energy for the xenon, Xc, atoms. Because the xenon atoms started at the higher temperature and lost kinetic energy to the helium atoms during mixing, the average kinetic energy of the say atoms must decrease. Determine the change in average speed for the xenon, Xc, atoms. The relationship between molecular kinetic energy, mass, m, and speed, v, is defined by the formula. Ke equals 1 over 2 mv to the power 2 because the mass, m, of a xenon atom is constant. If the average kinetic energy, Ke, of the xenon atoms decreases, their average molecular speed, v, must also decrease. Identify the correct choice. Since both the average kinetic energy and the average molecular speed of the xenon atoms decrease, the correct prediction is represented by option D. YODHERS wrong. Option A is incorrect. It claims that both the average kinetic energy and average speed of say atoms will increase. This is impossible because say starts at a higher temperature and must transfer energy to the cooler He atoms, leading to a decrease in its own kinetic energy and speed. Option B is incorrect. It incorrectly predicts that the average kinetic energy of the say atoms will increase. As the hotter gas in the mixture, say loses energy to heat to reach thermal equilibrium, causing its average kinetic energy to decrease, not increase. Option C is incorrect. It claims that the average speed of the say atoms will increase while their average kinetic energy decreases. Because kinetic energy is directly proportional to the square of the speed, K equals 1 over 2 mv to the power 2, a decrease in the average kinetic energy of particles with constant mass mathematically requires a corresponding decrease in their average speed. The correct answer is option D. Average kinetic energy of say atoms will decrease. Average speed of say atoms will decrease.